Assalamu alaikum. We are going to start differentiation today. So once again, the idea of differentiation is closely related to the concept of functions which you learned in mid 1. So the idea is, if you have a function, you can differentiate this, and after you differentiate, you're going to get the derivative, which is symbolized by the symbol f prime x or dy by dx. So just to keep things simple, let us use the symbol f prime x. So whenever you see this symbol, please remember this is the derivative of the original function. So this is the original function, also called the primitive function, and this is the derivative. So differentiation is just the process that gives us the derivative, that is all. So whenever you want to find the derivative, whenever you want to differentiate, you must apply one or more rules of differentiation. So please remember this: whenever you want to find the derivative, you must apply one or more rules of differentiation. So let's learn the first simplest rule. So this rule tells us, if you have a constant denoted by k, so in this case this k denotes a constant. In this case the derivative will be equal to 0. So you should remember this: the derivative of a constant is always 0. So let's apply this particular rule to a given situation. Let's say we have a constant function. Once again, you learned this in mid 1. So let's say we have a constant function which is equal to 10. As you can understand, this is just a constant. There are no variables here. So by rule 1, by the rule we learned above, the derivative should be equal to 0. So that's it. That is the first rule. Now definitely you're going to ask, what if we have a variable? Let's cover that rule here. So the second rule of differentiation is for the situation where you have a variable. So let's say our given function looks like this, where c is a constant, then we have a variable x, and x is raised to the power n. So you must remember, you should keep this in mind. In this case, only x is the variable, c is a constant, and n is a constant as well. In this case, to find the derivative, so we want to find the derivative denoted by the prime. The derivative is going to be equal to c into n. So the power n, this comes in front. As you can understand, this is coming in front of x. And then you have to subtract 1 from the power. So that's it, right? You just subtract 1 from the power. So there are just mainly two simple steps: bring the power in front and then subtract 1 from the power. That's all. So when can you apply this rule? For example, in a situation like this, let's say where we have a function that looks like this: 2 into x to the power 3. As you can see, let me use a different ink to help you understand this better. So as you can understand, this particular format, it perfectly matches with rule 2 format. So you have a c here, the constant 2, there is a x, the variable, and there is a power as well, in this case 3. So therefore we can apply rule 2. So what is rule 2 telling us? Rule 2 tells us to bring the power in front, multiply it with c. So bring the power in front, multiply it with c, and then subtract 1 from the power. So subtract 1 from the power. That's it. Right now you just simplify this expression and you will be able to find the derivative. So this is going to be 6x squared. So that's pretty simple. Now let's move on to a slightly different scenario. So we are moving on to a slightly different scenario. Let's say we have a case like this. So once again we have a function, and in this case we have a constant, and we also have a variable portion. So as we just learned, when we want to differentiate this function, when we want to find the derivative, first apply the constant rule here. So apply the constant rule. Since 2 is a constant, there are no variables, this should be 0. And in the second term, in the second expression, apply the second rule we just learned. So the power comes in front, and then the power minus 1 according to the second rule. So that's it, you end up with 4x cubed. So please remember this idea of differentiation. If, let me use a different ink to help you understand. So if you have a plus or minus in the middle, you can just differentiate the expression separately. For example, differentiate 2 first using rule 1, you get 0, and differentiate x to the power 4 next using the second rule, and this is what you get. So you can differentiate the expressions separately if there is a plus or minus. For example, if you have a minus, let's say x minus 3 x to the power 5. So once again, since there is a minus in the middle, you can differentiate the first expression separately. So since x is a variable, let me use a different color. Since x is a variable, you're going to apply rule 2, but please remember there is a 1 here, x is raised to the power 1. So this 1 comes in front of x. So this 1 comes in front of x. And 1 minus 1, remember rule 2. So we are applying rule 2 here. The power comes in front and power minus 1. Again, rule 2 is going to be applied here as well. So we are going to apply rule 2 on the second term. So 3 into 5 x to the power 5 minus 1. So what is the moral of the story? Please remember this, very important. If there is a plus or minus, in that case you can differentiate the expression separately. So there is a minus here, you can differentiate x first, and then you can differentiate 3x to the power 5 next, both using rule 2, because there is a variable x, right? Since there is a variable x, rule 2 needs to be applied, definitely. And in the next line you can simplify this expression. So let me help you out here. So please remember x to the power 1 minus 1 is 0, and anything to the power 0 is equal to 1, and you have 15 x to the power 4 here. So please remember anything to the power 0 is 1, so therefore you just get 1 here. So this is a convenient shortcut. You can remember the derivative of x is always 1, so that will save you some time, but you can also do it step by step, no problem. So you get 15x to the power 4. So there are a few important lessons here you should take before you move on. So first of all, if there is only a constant like this 2 here, then you're going to apply rule 1. However, if there is a variable x or this x, right? You must apply the second rule. Moving on. There's another important lesson. Remember, if there is a plus or minus, you can differentiate the expression separately. But if they are being multiplied, you cannot differentiate them separately. You need a different rule. So this is the third scenario, a different scenario. So in this case, we have a function where two different functions are being multiplied. So please note the difference. Previously we were adding or subtracting. Let me use a different color here. So previously you were adding or subtracting, but now you are multiplying, right? So this is multiplication. So in this case you have to apply a new rule. So this is called the product rule. Let me write it on this side. So makes sense, the product rule is for the situation where you are multiplying, right? Remember, product is related to multiplication. So since you're multiplying here, we are going to apply the product rule. So what does the product rule tell us? There's two ways of writing the product rule. I like to use this format, but they're the same, exactly same. So we are trying to find the derivative of this function. Please remember, we are trying to find the derivative of f of x. So to find the derivative, what you need to do is find the derivative of the first function, differentiate the first function. So g prime x, that means we are differentiating the first function. Keep the second function as it is. This is true in differentiation. If you differentiate one, when there is multiplication or differentiation, if you differentiate one function, the other function cannot be differentiated. So please note, hx remains as it is. We are not differentiating here. Now you put a plus sign and just do the opposite. Now you are going to differentiate the second function. So hx, this is being differentiated now, but now you cannot differentiate the first function. So the first function gx remains as it is. And this is the idea of product rule. This is the product rule. So when can you apply this particular idea? Please remember, whenever you are multiplying, whenever you have a function where there is a multiplicative format. So let's say we have this scenario, x square plus 1 into, let's say, x cube plus 3x. So definitely we can apply the product rule in this case. Why? Because the format matches. If you look carefully, right, this format matches with this format perfectly. So we have a gx here. So this is gx. If you compare it with the rule, so this is gx, and then you have a multiplication sign, and then you have the hx. So this is the hx in the rule above. So what is the rule telling us? If you want to differentiate this function, if you want to find the derivative, differentiate the first function, right? That is what the rule is telling us. So the rule is telling us to find the derivative, differentiate the first function. So please remember the prime, this prime indicates we are differentiating the first function g of x. So if you differentiate g of x, you end up with 2x2 minus 1. Remember rule number 2. But 1 is a constant, so the derivative of 1 is going to be 0. So this is the derivative. Let me use a different ink here. So this is the derivative of the first function. So this is the derivative of g of x, the derivative of the first function, using rule 1 and 2 here. But remember, if you differentiate the first function, you cannot differentiate the second function. So second function remains as it is. So x cube plus 3x is only copy pasted, no differentiation. Now we move on to the next part. So we are a little short on space, so most likely I have to reduce the font size. So remember, now we put a plus sign according to the rule. So please remember, we are applying the product rule. So this is our focus, the product rule. So this part is done. The first part of product rule is done. We did this here, and now we put the plus. As you can see, we are putting the plus, and now we move on to the second part. So in the second part, we are differentiating the second function hx. So now we differentiate the second function hx. So as you can see, we have a x cube, so therefore we apply the second rule, power comes in front, power minus 1, and we move on to 3x now. So again, you can apply the power rule if you want. So remember, x has a power 1, the power comes in front, and power minus 1, right? So we are almost out of space. So we have differentiated the second function h prime x. The derivative is this. Now please remember, you have to write the first function as it is. So g of x, this remains as it is, so there is no change. So we are going to write the second function beside this as it is. So x square plus 1 should be written beside it. So in the next line, let me write this more clearly in one single line. So please understand, we are applying the product rule. So let me just adjust the screen. So we are applying the product rule. So please remember, this is the product rule. Here I'm indicating by arrow. We are applying the product rule. So this is the first part of product rule which we did here, the first part. So I'll write this afresh. So remember, 2x2 minus 1 is x. You don't need to write the 0. The second function remains as it is, no change. And then you can write the next function, next part. So this is the second part of the product rule. This part, we are writing this here. So 3x square plus 3. Remember, x1 minus 1, x to the power 1 minus 1 is just 1. So you are left with 3. And in this case, the first function remains as it is, x square plus 1. So this is our derivative. You can simplify it further. If you want, you can multiply these parts and then add and subtract as well. So I'll leave that to you. So let's move on to one more example. So this is the last rule of today's class. So please practice these. Go to the textbook. In chapter 6, you're going to find, in chapter 7, you're going to find many examples, many exercise questions. So please practice them, otherwise you won't really understand them. So let's move on to the last rule of today's class, and this is called the quotient rule. As you can guess, the quotient rule is related to a division situation. So let's say you have a function where you are dividing two functions. So this is one function and this is another function. You are dividing them. So if you want to find the derivative, the first part is exactly like the product rule. So the numerator part, right, this part is exactly almost the same as product rule. So find the derivative of the first function, right? So find the derivative of this function. Keep the next function as it is. Remember, if you differentiate one, you cannot differentiate the other. So keep the second function as it is. And now put a minus sign. So this is the only difference with product rule. And now do the opposite. Now differentiate the second function in the denominator. But if you do this, you cannot differentiate the first function in the numerator. So keep the first function as it is. So that's it. As you can understand, the upper part is exactly almost the same as product rule. In the denominator, you just need to take the square of the denominator function. So you don't need to differentiate, just take the square of the denominator function. Whatever is in the denominator, just square this. So let me help you understand this using an example. So let's say, just give me one moment to adjust the screen. So let's say you have a function that looks like this: x cubed divided by x squared plus 1. As you can understand, the format of this function matches the format of the quotient rule. So the function is like this, and so I'm sorry, the one got erased. So the function is like this, and the quotient rule is also like this. The format is like this as well. So definitely on this function you can apply this quotient rule here, right? So this rule can be applied to this function. So what is the rule telling you? Let's slightly move the screen. So please remember, now our focus is this rule here, right? This particular rule is our focus. So this rule is telling us, if you want to find the derivative, then differentiate the first function. Differentiate the function in the numerator. So in this case, this is g of x. Please remember, whatever is in the top, that is g of x, and whatever is in the bottom, that is h of x. So the rule is telling us to differentiate the first function in the numerator. So we have to differentiate x cubed. So 3 comes in front, x cubed minus 1. Now keep the second function as it is. So hx, the second function, it remains as it is according to the rule. So please remember, we are just following this instruction, we are just following this rule. So the rule is telling us the second function, h of x, will remain as it is, no change. Now put a minus sign. So we are moving on to this part of the rule here. So the second part of the rule is telling us, now take the derivative of the second function h of x. So this is h of x. So we are going to differentiate this. 2 comes in front, x2 minus 1. 1 is a constant, so this becomes 0. And now the rule is telling us the second function will remain as it is. So g of x, the first function, the first function g of x will remain as it is. So the g of x, the first function, remains as it is. So you can see a nice pattern, right? If there is multiplication or division, you can differentiate only one function and the other function will remain as it is. In this case, we are differentiating the second function, the first function remains as it is. So this applies whenever there is multiplication or division. And please note, there is the denominator part of the formula. So in this part here, we are just squaring the denominator function. So h of x in this case is x squared plus 1. So just square that, x squared plus 1 whole square. And now you can simplify this if you want, up to you how you want to do it. So let me just simplify this. So this is 3 x square into x square plus 1 minus 2x into x cube. You can simplify this further. I'll leave it to you, it's easy. No need to simplify this denominator part. If you want, you can apply a plus b whole square formula, but I don't think that's necessary. Anyways, this is your derivative. So we learned 4 rules today. Please try to understand when to apply which rule. There's a lot of practice questions in chapter 7 of the book, so please go through them. They will be important for the final exam. That's it for today. Thanks for listening. Take care, stay safe.